Today, let's talk about the trachea at Health Next. Let's see what causes this. The trachea, also known as the windpipe, is a crucial part of the respiratory system that transports air to and from the lungs. It's a tubular structure connecting the larynx orifice box to the bronchi large airways leading into the lungs. The trachea is formed during embryonic development, specifically starting around the 4th week of gestation in humans. It originates from an outgrowth of the primitive foregut, which is the precursor to the gastrointestinal tract. This outgrowth is called the respiratory diverticulum or laryngotracheal diverticulum. Here is the breakdown. The process begins with the appearance of the respiratory diverticulum on the ventral wall of the primitive foregut. Initially, this diverticulum is continuous with the foregut. However, a crucial longitudinal ridge, called the tracheoesophageal septum, forms. This septum gradually pinches off, separating the respiratory diverticulum, which will become the trachea, and lungs from the dorsal portion of the foregut, which will become the esophagus. Defects in the formation of this septum can lead to conditions like tracheoesophageal fistula, where there's an abnormal connection between the trachea and esophagus. The proximal part of the respiratory diverticulum remains tubular and forms the larynx and trachea. The distal end bifurcates into the primary bronchial buds, which will go on to form the lungs. Molecular and genetic mechanisms. This complex process is tightly regulated by various signaling pathways and gene expressions. Key players include WNT, BMP, retinoic acid ARA, SHH, or what we call sonic hedgehog, and FGF, which you can call fibroblast growth factor signaling pathways. These pathways are essential for the proper patterning, cell specification, and morphogenesis of the trachea. Genes like SOX2 and UNKX221. These are crucial for the overall development of the trachea and respiratory system. Mesenchymal epithelial interactions. There's crucial crosstalk between the epithelial cells lining the developing tube and the surrounding mesenchymal cells, which give rise to the connective tissue, cartilage, and smooth muscle of the trachea. The mesenchymal cells are responsible for forming the characteristic C-shaped cartilaginous rings that provide rigidity to the trachea. Briefly, the trachea is not caused by something in the sense of an illness or event, but rather it is formed through a precisely orchestrated series of developmental events during embryogenesis. Any disruptions in these intricate processes can lead to congenital anomalies of the trachea, such as trachealogenesis, failure of the trachea to form, or tracheal stenosis, or what you can call narrowing of the trachea. Thank you for watching a Health Next video. Subscribe for more if you want.